So far in this unit, we have looked at strong acids, strong bases, weak acids, weak bases. And so here's the last type of solution that we should consider. What about just a salt? What about like sodium chloride or potassium nitrate? What about just a regular ionic compound? I put those in water. Will the final solution be acidic or basic? Are there any extra hydrogen ions? Are we producing anything that's going to remove hydrogen from the solution? So when we consider acid-base properties of salts, we have to kind of break them apart and consider both the positive cation and the negative anion. Some salts are really neutral. An example might be something like sodium chloride, like salt. So when I think about the sodium ion and the chlorine ion, I'm going to ask myself two questions. Question number one, can either of those ions produce hydrogen and act like an acid? Well, that should be an obvious no, right? No, I mean, if I put salt in water, the sodium ions and chlorine ions are obviously not bringing any hydrogen into the solution. Then the second question I ask, okay, could either of those ions remove hydrogen from the solution? Now I'm really concerned more with the negative ion of my salt, so that chlorine ion. Could the chlorine ion react with hydrogen and remove it from the solution? Well, I mean, if it did, it would form HCl, but HCl is a strong acid and it stays dissociated anyways. So we said earlier that the conjugate base of a strong acid is a terrible base. It doesn't pick up hydrogen at all. That's why it's a strong acid. It stays dissociated. So both ions are 100% neutral. Neither produces hydrogen and neither of them can remove hydrogen. Another example might be something like, I don't know, potassium nitrate, where both HCl and HNO3 are very common strong acids. They're probably the two most common strong acids, hydrochloric and nitric. And so again, I would ask myself the two questions. Can either of these ions act like an acid and produce hydrogen? No, there's no hydrogen there. And then the second question, again, mostly pertains to the negative ion. Could nitrate react with any hydrogen present and remove it from the solution? But if it's just going to form a strong acid, it'll ionize and dissociate right away. So both of these would be examples of salts that are 100% neutral. Now what about a salt like sodium acetate? So sodium acetate, C2H3O2. So I ask myself the same two questions. Can sodium or acetate produce hydrogen? No, I mean, there's hydrogen in the acetate ion, but that's like a covalently bonded structure. It's not going to give off hydrogen. And obviously sodium is positive, but it's not going to produce hydrogen. So no, nobody's going to act like an acid and produce hydrogen. Then I go to the negative ion. And I say, okay, what about that acetate ion? Could that guy react with hydrogen and remove it from the solution? Well, here's where they're giving me a little hint. They're saying, hey, by the way, the Ka for acetic acid, in case you weren't aware, is small. 1.8 times 10 to the negative fifth. I don't care what the number is, but when I see that it's small, I know that acetic acid is a weak acid. Now, in the first example, again, they often don't give me Kas for strong acids. They're ginormous, and they do kind of expect that I would recognize hydrochloric or nitric as being strong acids, and their conjugate bases are terrible bases. But there's a reason why acetic acid is a weak acid. And it's because the acetate ion is really attracted to hydrogen. That's why it doesn't dissociate by much. Oh, so way back in the beginning of this unit, we kind of mentioned that the conjugate base, which is this acetate ion, the conjugate base of a weak acid is a pretty good base. That's why the acid is weak, because that acetate has a pretty strong hold on the hydrogen ions and really doesn't give off much hydrogen in solution. So now I've got one ion that's totally neutral, but this acetate ion is a base. And so this solution will be slightly basic. Now, obviously, it might not be as basic as like sodium hydroxide, but I am producing an ion that is mildly basic. Consider an acidic salt, something like ammonium chloride. Ammonium chloride, NH4Cl. Okay, so I ask myself the same two questions. Question number one, could either of these ions produce hydrogen? And then I actually say, ooh, well, maybe. They're giving me another hint here that Kb for NH3 ammonia is small. Now, number one, they're telling me Kb. So I know that this thing is a base, which not a lot of people would look at NH3 and be like, oh, that's totally a base. Often we would look at that and be like, I don't know, there's hydrogen, but there's no hydroxide. Well, it's going to be present, it's produced in the solution when the NH3 reacts with water, right? So we have the NH3 that could react with water from the solution. And if this guy's a base, it's going to have a tendency to take hydrogen. Well, the only other source of hydrogen in the solution will be the water molecule. So we'll form that NH4 ion, and then here we go. The solution is basic. I will produce some hydroxide. It doesn't come directly from the ionization of NH3. It actually comes from the water that's just in the solution. Now it's weak, so this doesn't happen 100%, but there will be some hydroxide in the solution. So they are giving me the Kb, which hints at the fact that the NH3 ammonia is a base. And then on the product side, this NH4 plus is its conjugate acid. If this thing were to go in reverse, then the NH4 would have to give back that hydrogen. So yeah, NH4 has an extra hydrogen that it could donate. It's positive because it has an extra hydrogen. So yeah, this guy could act like an acid. Well, then it's bonded with chlorine. And we said earlier, chlorine comes from HCl. So could chlorine react with hydrogen and remove it from the solution? Probably not. If it did, it would form a strong acid and it would split apart or ionize immediately. So the chlorine is totally neutral. But now I've got one ion that's acidic, and so my final solution is slightly acidic. So for any salt, we ask ourselves two questions in considering each ion. Can the positive ion produce hydrogen? Is it positive because it has an extra hydrogen? Well, then that positive ion is going to act like an acid. Then I also consider the negative ion. Could the negative ion react with hydrogen and remove it from the solution? Meaning that the negative ion would come from a weak acid. It would be the conjugate base of a weak acid. So it's pretty attracted to hydrogen. If the answer is yes, then that ion can act basic in solution.